This is 7.4 Division Properties of Exponents, page 439. The objectives of this lesson are to divide powers with the same base and to raise a quotient to a power. Here, everything is going to be in some type of fraction or division format. When you're dividing the same base, you're going to subtract the exponents top to bottom. 2 to the 6th power divided by 2 to the 2nd power will be 2 to the 6th minus 2. Then the final answer would be 2 to the 4th. If you have subtraction top to bottom, like in the second example, x to the 4th over x to the 7, and you end up getting a negative answer, just like in our first lesson, it must go to the denominator. Whenever you have fractional exponents, the same thing will apply. You'll subtract top to bottom and subtract the exponents for your final exponential answer. Raising a quotient to a power will be whenever you have a fraction raised to a single power. The power base will get the exponent distributed to both components. A to the n over b to the n, where a does not equal 0, b does not equal 0, and n is a rational number. So for 3/5 to the 3rd power, the 3 would get distributed to both the 3 and the 5, and then you would simplify. Xy to the 5th, both components would take the 5, x5, y5. These are not subtracted because you have a different base, numerator x, denominator y. AB to the 1/2, both get the fraction of 1/2, and that is the simplified form. In problem 1, dividing algebraic expressions, you're going to find the simplified form of each expression. For part A, I have x to the 5/2 power divided by x squared. I have the same base of x, and I'm going to go from top to bottom, so 5/2 minus 2. Your graphing calculator will do this for you automatically, but if you didn't, you would have to have the same denominator in order to subtract the fractions, so I would have 5/2 minus 4/2. 5/2 minus 2 is 1/2. The final answer would be x to the 1/2 power. For part B, I have m squared n to the 4th over m to the 5th n to the 3rd. I'm going to do each base and exponent power separately. So first, I'm going to do the m's, 2 minus 5, then the n's, 4 minus 3. I would get m to the negative 3rd power and n to the 1st. Because my m has the negative exponent, it would need to go to the denominator of my fraction. So n over m to the 3rd. Also, something that you can identify to help you check your final answer. Looking at my original problem, my highest exponential value of m is 5, and it's in the denominator. On my final answer, my final m is also in the denominator. For my powers for n, my highest exponential given is 4, which is in the numerator, and my final answer for n also remains in the numerator. Now press pause on the video and go to Nearpod to complete Got It question number 1 for 7.4. Problem 2, dividing numbers in scientific notation. Population density describes the number of people per unit area. During 1 year, the population of Angola was 1.21 times 10 to the 7th people. The area of Angola is 4.81 times 10 to the 5th miles squared. What is the population density of Angola that year? First, I'm going to divide 1.21 times 10 to the 7th, which is the number of people, by 4.81 times 10 to the 5th, which is my area. Because the coefficients 1.21 and 4.81 don't have exponents, I'm going to divide those just as they were regular coefficient numbers. 1.21 divided by 4.81. Then 10 is the same base, so I'm going to subtract the exponents of 7 minus 5. 1.21 divided by 4.81 is about 0.252 times 10 squared. Because I have to put my final answer in proper scientific notation, I would have 2.52 times 10 to the 1 power. Now press pause on the video and go to Nearpod to complete Got It question number 2. This is problem 3, raising a quotient to a power. What is the simplified form of z to the 2/3 over 5 as a quantity raised to the third power? To begin this problem, we're going to distribute the outside exponent of 3 to both the numerator and the denominator of the fraction. I would have z to the 2/3 raised to the third power and then 5 raised to the third power. Because my numerator has a single base with a power raised to a power, I would multiply the exponents 2/3 and 3. I would get z to the 6 over 3 divided by 5 to the third. Now I'm going to simplify my final answer, and I would get z squared divided by 125. Now press pause on the video and go to Nearpod and complete Got It question number 3. This is problem 4, simplifying an exponential expression. What is the simplified form of 2x to the 6th over y to the 4th raised to the negative 3 power? Just like in the previous example, I'm going to take negative 3 and distribute it to every component in my numerator as well as every component in my denominator. I would have 2 to the negative third, x to the 6th to the negative third, and y to the 4th to the negative third. That would simplify as 2 to the negative third, x to the negative 18, and y to the negative 12. Because all of these powers, 2 to the negative third, x to the negative 18, and y to the negative 12, have negative exponents, all three must be moved. So I'm going to be taking y to the negative 12, moving that to the numerator, and taking 2 to the negative third and x to the negative 18 to the denominator. I now have y to the 12th over 2 to the third, x to the 18th. The simplified form of this answer would be y to the 12th over 8x to the 18th. Now press pause in the video and go to Nearpod and complete Got It question number 4.